Hello, good morning, dear colleagues, guests, partners, students, teachers. I'm very glad to see you here at Šiauliai University. We have one of the final stages of our CONUS project. We have an international practical conference here today, which has a plenary session, 2.5 hours with presenters from industry, from science institutions, from students, from our project team. The name of the conference towards Smart Industry Lithuanian and Latvian regions, opportunities and challenges. We try to think and talk about what is a smart industries, how we are going to this smart industry. We have good examples of already Industry 4.0 at our city. Of course, there are some many opportunities and so many challenges. So I'm very glad to see our acting director, Šiauliai, and I'm inviting Šiauliai for welcome speech. Thank you.
Dear guests, dear colleagues, it is a great honor for me to congratulate you to Šiauliai University. Šiauliai has a long history as an industrial city, and this faculty was a good impact for this process. And new technologies, developing industry, and I wish that this conference will be a good impact for this. Good luck and see you in Šiauliai.
Thank you. Some words about organization of this event. Maybe I will explain a little bit the agenda of our meeting. Yes, we have, if you look at the agenda, you maybe see there are some presentations, 15 or more or less of each, with experience from industry, from science, technology, study institutions, and it starts from 9:30. Unfortunately, under Aksel from Latvian Ministry of Environmental Protection and Regional Development is absent. We apologize for that, and maybe we will finish a little bit earlier than it's written in agenda, and after that we will have lunch in the lobby, not here, but when you go outside from this place, you will see some dishes. Please enjoy the food, and it will be about 12 o'clock. There's my colleague, project leader from Latvian side, Edmunds Kavanis. After presentation, we will sign some declaration about how to not to end this like stop, and we will continue our cooperation in what we were doing during this project. And after the lunch, we invite you to practical seminars, which are related. We have parallel sessions which are related to computer-aided design and manufacturing and industrial robotics. You are welcome to join the practical side of this conference. And these rooms are ground level, zero level of this building. And we will see signs, and we will talk about how to reach this. Okay, that's not a problem. And yes, do you have any questions? If you have any questions, please ask me or my colleagues about. We are talking about people who came from not university, from our guests from other institutions. So, According to schedule, the next presentation comes from me and my colleague Edmund Stamanis. I am project CONUS leader from Lithuanian side. As I said earlier, Edmund is project leader at Lietuvos University side. Now I will talk about our project in very short way. If you have any questions, you can ask me. And the title of this presentation is Project CONUS, the Accelerator of Regional Development Projects. Hope that everybody understands English. If you need some summary in Lithuanian, please tell me after the presentation. I will tell a few words in Lithuanian. Okay, project overview. Under Apsis absent, I will talk a little bit about this program which helped us to reach these goals, and we will see later in my presentation. And the project overview, the project is called Interact project, Latvia-Lithuania cooperation project, which helps in regional development. And the program has some priorities. One priority we applied for is support to labor mobility and employment. And the specific objective of this program is to increase job opportunities by improving mobility and workforce skills. We are oriented in improvement of workforce skills in engineering, metal processing, and robotics, and some other major fields which are demanded by our industries. And if you talk in one sentence, what is the overall objective is to develop and improve lifelong learning activities. We are active to work with school children, with students from our university, students from other institutions, as well as unemployed people, people from industrial companies, and these are all lifelong learning. You should learn all your life if you want to succeed, because technologies are evolving very fast, and you should learn every day to not to let yourself behind the progress. And of course, in the next few words, to support labor market competitiveness. And our regions have some problems related to immigration, and we supported or accelerated labor market competitiveness, which we should see some numbers, some paths, how we achieve that. And project partners. Šiauliai University, Lietuvos University, we are good partners. We participated in many projects, not related to engineering in the past. We have new projects, new plans for new projects, and we have some skilled staff, teaching, science staff, also good modern technical base, and we have a good contacts between our institutions. I think we are further strengthened to lead into new projects. And we're talking about project focus. So focus it has, let's say, 5 big parts. And we updated study programs and created new ones. And also created new training programs, short-term training for people who are working in institutions and employed people 16 hours or so to work, to know how to work with robots, to specific software and so on. And we established new labs, 3 very new labs, very modern labs. And I think some of them are most modern in whole regions. And also we created new procedures and opportunities that enable lifelong learning. We created books, video materials, and other procedures that help to know things better, which are very demanded by industry. Okay, we, as universities, we are a source of new knowledge, and we spread this knowledge to outside world, and we think we did a great job. That we are something that was done never ever before, and we are happy for it. We have such good partners, and another big part is workforce supply and demand map, which helps to find people for companies and for people to find jobs and industrial sites. And target groups, in short, we have target groups higher education and research, let's say colleges, universities, as well as education training in schools, vocational schools, secondary schools, gymnasium, and so on. Also enterprises, as well as big, small enterprises we reach, business support organization, general public, like people who know, if you want to get new knowledge related to engineering, public authorities such as municipalities and other interest groups and non-government organizations. Okay, let's talk about results. What we reached, as I talked later, we established new laboratories, one or two laboratories at Šiauliai University, one at Latvijos University, one is related to industrial robotics laboratory. I think it's most modern in all Lithuania, this industrial lab. The robotics laboratory, we have an opportunity to visit this site, as well as computer-aided design and manufacturing laboratory. We had some practical activities to see what's happening in these labs. In Latvijos University was robotics and material testing laboratory established, which is more related to science, to research, to applied research, and we see we have a good synergy of these laboratories. These are more related to industrial skills, these are more related to research, which help us to test something we made in these labs, and it's very good for us. Okay, in short, industrial robots lab at Šiauliai, we have two robots, one welding robot, one universal robot. We call it universal robot, which can mill, which can pick, we provide it to perform pick and place operations. You will see as you wish how it works in reality. Also, we purchased very modern software which helps us in robot simulation, in robot programming, offline robot programming, which is very demanded by industry. That robot should be programmed as quickly as possible. And also 3D factory simulation, which helps to try and to design new concepts, how to improve production processes or create even new. Also computer, we have a computer-aided design and manufacturing lab at Šiauliai University. We purchased specific software for computer-aided design and manufacturing process, like metal sheet processing, milling processes, and as a software. As a hardware, we bought a CNC milling center, and what we have a possibility to design new things using advanced tools and make it using real industrial machinery. We bought some new computers, 10 new computers with powerful processors, GPUs, and we are happy. Okay, it's one lab at Lietuvos University. I think in every university, students should have opportunity to learn how to program industrial or universal robot, and we bought ABB, small robots, we call it the training kits, with necessary training material, as well as another software, RoboMaster and Mastercam for milling, for robots programming, and some very good machines which are used for testing of materials. Microharness tester, drilling and polishing acting machines. Maybe Edmunds will take talk about more, or Sergei will have a presentation about his research, and he's using these machines in his research, and these are already used. I will show a small video about our new robotics.
Esame Šiaulių universiteto robotikos laboratorijoje, kurioje turime dvi gamybinės robotinės celes. Prieš šios frezavimo stakles, kurias pagamino amerikiečių kompanija Haas.
So it's kind of easy what you will see after the lunch in our 04 during workshops. and another short video how this big machine was entered our building. Okay. We created two project websites, one for Latvian side, one from Lithuanian side. The addresses is quite similar, CONUS.vu.lv and CONUS.vu.lp. Letter L is missing, so it's my mistake. And you can see all the information we created about what study programs we do, what training programs we are offering you. In your package you see some flyers. Still training programs are available at least for 1.5 months. You can use this opportunity to learn new things. And these training programs are in short. I will not explain everything. You will see in the internet site. These are in Lithuanian material. Some information will be in Latvian side. We are focusing on industrial robotics, in CNC machining, programming, SolidWorks, AutoCAD, and these design tools, computer design tools, which are demanded by industry. This kind of flyer you have, it's some information available. If you have questions, you can write an email, and we will answer to these questions. Okay, I'm very glad for this result, as we improve teachers' qualification. I see many examples, and some advanced equipment was bought, and I think it's used very rarely or never used, and used for just exhibition, for excursions. And I'm glad that we have skilled persons which are able to use these advanced machines like robots, like CNC, and the teachers improve their qualification at internships and industry. They learn how to program robots, how to work with CNC machines, and we've talked many times with industrial people what is demanded by industry nowadays, and I'm very glad for it. As well, some teachers participated in work in state-of-the-art level exhibitions, like in Lithuanian, technical Latvian exhibitions for technology, as well as two teachers were last year in Hanover Messe in Germany. And we saw what is really is Industry 4.0 and shared their experience with our team, with students, and we're glad that we saw many good things that we should know about. Books, we created 10 books. These books are available on these sites. These books are very new. It's written for robot programming, for CNC, and these books never ever been in Lithuanian, Latvian language, I guess, and we have opportunity to read these books. Also, we created more than 30 or 40 videos, and it's counting. We created new videos and putting them in YouTube channel Project CONUS. You can visit this channel and you see many videos from industrial sites, from our labs, from exhibitions. What we did interesting, we putting it on YouTube channel and it's available. You see, okay, we presented our project in quite many events, like industrial exhibitions, like science festivals, like in meetings of some clusters, and we make people familiar with what we are doing. And these some photos from industrial exhibitions from Researchers Night event, when we present our project, what we are doing, what people can get from this project. And also some short video from exhibition which was at Šiauliai last year. We have okay, so sound is robot, we brought robot to scientific or industrial exhibition for Šiauliai, and it's not really industrial. Remove the sounds. brought robot to Šiauliai Arena, and some people saw this kind of machine first time in their life, and rewarding what we said that it's nothing interesting, you can push the button and it works like this, and we try to explain that it's huge work behind how to program this robot to perform some operation and building some weights, building this trajectory and growing level by level some metal wire, and you will see in other workshops how it looks like, and we spread this new knowledge, bring machine to industry. Some ask why are doing this, because it's challenging to remove this from here, to bring someone, but our goal is to show technology for public people how it looks like. Okay. And some moments of trainings, we performed so many trainings, we performed trainings for 1 year and still going, these trainings are still available, and these are moments how it looks like. People, when we working with real machines, we form groups, 3 or 4 people at maximum, because they should learn things using web handwork, because not to look at how the teachers are doing, what they're doing, and some other students form groups. We'll 2, 3, maximum 4 people to work with robots, to work with CNC for computer exercises, like for computer designs, and for groups more, 10 persons or even more. We also provide training for other institutions. From the Ukrainian side, we provide trainings for Šiauliai State College, for Šiauliai Polytechnical School, I guess it's called like this, to Vocational and Training Center at Šiauliai. We used knowledge how to program industrial robots, how to work with CNC machines. Also, we provided many activities to school children to make familiar to modern industry, and the goal behind was to make these people, young people, know what real industry is look like. It's not like hammer and axe or some other tools. We think that nowadays engineering is related to more programming, to material processing, and we invite them to our labs to show how this process look like in our side as an academical side. And after we invite these groups to industry to show how looks modern industry in these days. And maybe sometime after we will choose engineering studies, and companies will have good talent pool to pick the best people for their sites and courses that will find. Workshops. Also workshops is like we will have today. It's 1 hour long workshop to show something, to explain something, to answer the questions, and to make demonstration. Maybe after that some people are taking training courses, 16 hours for trainings to make things, and to go deep into some details. And after these trainings, some people will change their work or find new work in metal, especially metal processing industry. And also public lectures. We public lectures is not like teacher talking, somebody listening, but also this interactive explanation of some things. It's maybe in a more academical way, but it's also I think it was very interesting to our target groups. Also joint activities of project teams. We have different backgrounds of our project teams. We are more, Šiauliai University are more engineers. Our Latvian side, we are more scientists, researchers, and we have a good synergy. How we taught them how to do engineering, we taught us how to maybe do material processing, and we find many synergies in that way also. You see some pictures from our joint trainings of project teams. Also students, we brought some students in Latvia. Now students from Latvia came here for joint courses, and yesterday day before yesterday, we have a joint, Latvian teachers provided joint courses to our students. Yesterday our guests were participating at very good excursions to industrial side. We're very happy. I wish to thank all our colleagues from industrial side that gives us an opportunity to participate in this very interesting events. And they are very kind to not ignore us. And some statistics. When we're doing reporting, these numbers are very important. I try to not to bring very many numbers, but this is a like summary what we reached when we talk about some statistics. We have trainings, workshops, public lectures, this is used as our main activity in the second year of the project. And we reached more than 400 number of participants for training and scouting. Also workshops, 200 people, public lectures about 180, with students to more than 200 people, mostly schools in the universities. Sites and scouting, and we have an opportunity to wish. There's some people, I see from people from not from university and from our project team to participate in that. And we talk about number of companies, we reach more than 50 companies, and these companies are already known in our region, and there are some locals of these companies. Some of representatives will give a presentation today about their companies. And we are very happy to have such good partners. And in summer, three results, as a main results, we supplied competencies and skills meeting the industrial sector needs to our trainings to improve study programs, created new books, and this is most important task. And when we talk about what is interesting today, now is support for professional guidance of school children. We have now, as we talked with our colleagues in Latvia, the same problem is in Latvia, and the same problem I think in all Eastern Europe, that school children are not guided to how to choose where future profession of the future. And I think it's a bad system of examination that young people at the last 3 years of their school life, we are thinking more about examinations, how to pass examinations, than to what is interesting to them for their future. And it's not changed. I think we try to change that, to bring some people to industry, young people to industry, and I hope that some of them or part of them are interested in engineering things. Also, we are open to cooperation at various projects, and we have good equipment. We have several companies already in joint projects with applied research using this kind of equipment. And it's for example, for today or tomorrow we'll talk with some companies how we can cooperate in engineering. So I wish to again thank all my colleagues from Šiauliai University, from Latvijos University. We did a great job. Also, I would like to thank our companies for cooperation. I would thank our referees missing to our authorities, local authorities, for support. We have some problems with that, but we solved it, and we are happy that we have this project. And the project is ending in 1.5 months, and we make, I think, very good work, and we are making a good work, and we will make a good work to make the progress, and that our regions will be successful. Okay, thank you very much for your attention. If you have some questions, maybe in Lithuanian and in Latvian, you can ask, of course, or talk after the presentation during the lunch. Thank you. Reikia kam nors lietuviškos santraukos, ką aš čia pasakoju. Gerai, ačiū, tuomet English. So, according to our schedule, I would like to ask Justinas Berneckis from ROL Lithuania to make his presentation about Industry 4.0. I should say, Justinas, that the Latvian team was very happy to visit your company, and I guess we have very good experience how industry should look like.
Okay, good to see you. I'm Berneckis from ROL Lithuania. Some visited yesterday our company, so I will present a little bit, maybe not so many about our company, because we saw in reality how it works, but about like basic things, what is nowadays industry, how young people are looking at this, and trends what is going on. So if you have any questions, you can stop me and ask directly or after presentation. So it's no problem. Okay, so about industry, and it's we have living in fourth right now, but we have industry first one, second, third, and current four. Yeah, first one was a steam engine. Yeah. Second was mass production line, like in Cincinnati and Ford manufacturing 14. Third one was PC-based system, robotics, PLC, and current is like cloud-based system, cyber system, Internet of Things, and so on. And these industries change very fast, if you're looking at nowadays. So, and why we call industry 4.0, it was in Hannover Messe in 2011, if I remember right, in Germany. And what it connects, like interoperability, virtualization, decentralization, real-time capability, service orientation, and modularity of it. In different regions, in Japan, in the United States, we are calling a little bit different name, but it's like base principle. And what we will get from this one, that we have documented process here, and we have live process, and it's joined in one flow. Before we have only like documented process, we will not have live process. Right now it's current joining to one flow. And here it looks like thematic, but always we have like company like management level here. We have production management, cell process, manufacturing. Right now with limits breaks, and even manufacturing cell process can directly connect to ERP system. This one is very good slide, but we have like hierarchical structure, and right now it's changed to cyber system where we can even track our smart products, cars, phones, computers, wash machines, whatever, kitchen, for these ones, and can provide better service for this. About chance, yeah, who will win and who will lose on this one? So it's 2014 yen if we are looking, and trends is like that we have like products, about 70%, 24% of service and software. So it's changed that benefits will be for products going down a little bit, service up, and software. So it's very well-known example. It could be the Airbnb, Facebook, this one, Spotify, Netflix, all these companies. But we are selling service. We are not selling like a product, but we are selling service. Like Facebook making the biggest like newspaper right now, yeah, but they are not creating any news. They don't have a journalist or Airbnb. This one they don't have any hotel. They are biggest right now. So it will be changed. Here you can on the internet, this one web page, you can find how fast it's growing up. The gigabytes, how many minutes you can see on internet. for this one there, I just turn on, yeah, and you can see gigabytes, 1 in 10 seconds, how we post, likes, what's trend going on, tweets, LinkedIn search, Instagram, and it's counting average. Sales on Amazon, yeah, like biggest right now store. Messaging and WhatsApp and so on, so it's changing very fast. And all of these companies are making not only products, but we are selling a service. And it's like a business model that we have only product. When we start to sell product and maintenance, service for product, the third business model that we are selling product and availability, output guarantee from product. And the business model number 4 is that we are selling or paying by hour. Yeah, for example, Rolls-Royce for aircraft engines, we don't sell any for Airbus, for Boeing engines. We are selling pay by hour. So how many hours it runs, you are paying for Rolls-Royce. Or this one, we are not selling. So we have a cash flow, we are making for the service and so on. So it changed dramatically. And industries like in Germany very popular, like for companies who need manufacturing companies supply a high pressure area for machinery and so on. So we're paying for how many consumption they are using. And someone sends to your service for this. Okay, necessities of industry, yeah? Why we need that of demographic development. It's the same in Ukraine, Latvia, and Baltic states, even in Germany, and in Scandinavia. I will show a graph of this one. About young employee who is coming in the market, we are a little bit different thinking, and risk. We will not go, so we can lose market or even bankrupt. Yeah. So here is a demographics, yeah, from Lithuania. It's like trends going down. Our population, so it means that it will be a lower amount of persons who can join the work. Yeah. If you look at to German or another country, it will be similar, maybe not so dramatically. So we need to change how we are working to use less human forces. So we cannot recruit the right person, talent, and so on, because we have a lower possibility to choose. Second thing is that young people grow up with technologies. Yeah, even small kids for 2 years, even 3 years, they can use smartphones, tablets better than maybe my parents or something like that. Of this one. Here I have a nice picture, and maybe you can see what is in this one picture. Yeah, what? Someone knows? Here is the Pope inauguration in 2005, yeah, and 2013. So here I think it will be a little bit better. Someone has, yeah, phone here, and 2013 everyone was streaming online. This one inauguration. So how many? 10 years? A little bit, yes, 8 years, and what is the difference? About if you are not doing this one like Kodak is a good example. Yeah, everyone knows Kodak, yeah, and maybe has some cameras, making instant cameras and so on. And in 2000, I think 2008 or something like, maybe like in 2000, it was a decision made. We were very good on photo cameras, on this one film, yeah, biggest supplier for all the world, and we have very good manufacturing plants and so on. And we made decision do not invest in technology like digital cameras. And I think everyone remember when we had film and it becomes digital. So in 2012 we bankrupt because nobody will start to use it. It's similar with Nokia happens, and it's possible to find out. We should recognize where is the point to invest and to change our product. Qualification, yeah, and what will affect this one, yeah. So the risk that some position can be digitized, that we will not need more in the future. It's tax consultant, bookkeeper, real estate agent, Schauspieler, yeah, even fire extinguisher and so on. So it's a risk that in nearest future, in 10 years, this will be done by artificial intelligence or some other technology. So, and then a lot of persons are educating right now on these specialties. Who will be winners, yeah? So it's like big data analyst, IT, programming, software development, and other small technicians. Yeah, it's possible to find on the internet even page you can write a specialty and its chance 20 years it will be needed this one position or will be lost. And who is, yeah, winners and losers. So if you have like a company, yeah, with very low skill and very high qualification, and here is amount of numbers. So with very low qualification today we have not so many, but in the future, this one industry we will need much more for lower qualification, very simple operation, which machine cannot do, and more people who has very high qualification to run this machine program, understand big data analyst and so on. So who is a loser and who is a winner? Here is a gap. And here is a challenge to rise in a little bit more of this trend. So here is challenge, here in the university with laboratory that you can train a person and train and educate. It's go. Okay, here is our basic about industry, yeah, and about our company. You will visit us yesterday. So we own 25 square meters, what we have using, 6,000. Today it's about 450 employees working, and in Šiauliai region for 30 years we are working here. I think it's the biggest investor in this region. Here is a picture from our company. You can see a solar plant on the top. So we are producing energy like this. Nowadays we are supplying for our this one automotive factory about 50% energy nowadays, like this sunny day spring. So why we did this one factory? This one automated. It's to reach our capacity for new market, to beat market price, yeah, competitors from China, maybe Vietnam and another cheap market, and to have like a base platform for manufacturing, and we can copy and paste made in Brazil, United States, and so on. What it makes special here, I will not show a picture of our factory because you saw that. What is different with the regular factory, because we have robots here in the university, we have welding robots in other companies and so on. It makes complexity with integration, what we can in one system, yeah, big data, all machines report to one system of this one. So we can control, monitor for only our existing ERP system. So all ABB robots, this one HGV is material warehouse connects to one system and report, and we can track in real data. This one. So this all was developed by ourselves. You cannot find in any country. This complexity system and safety system, it's unique. This one I take a picture. Maybe someone saw that. We have 1 year for this one factory development. So we didn't use, we didn't have possibility to use augmented reality yet for this one. So we a little bit play on this huge paper to look how its flow works and so on. We will not make any mistake on this one. But nowadays you can do like simulation, virtual tours and so on for this simulation before you will implement it in reality. Because if you make mistakes during the implementation, you cannot maybe. It will be too late. And I think yesterday we didn't see this, but we use data tracking. You can track each machine, where it's generating output, what is availability, output per cycle time, average cycle time, occupancy, stop time, stop reason. Yeah, I mean, as much as possible to get this one. So nowadays companies are getting much more data and we can get benefit for this one. So this one can dashboard, each machine can be tracked directly. And you can know what is like your bottleneck and what is a problem, maybe it's the same repetitive problems and so on. See different machines here. And to run this type of factory you need some education. So in the market it's hard to find right now. It's possible to find like in university for robot operators, SolidWorks. Here you are providing in Šiauliai University can be found. What else we have here? This one has milling machine, so we send you to this one laboratory to train. But we have a lot of internal training, quality training, ERP system training and so on. But we should do by ourselves. And we were sending to ABB Czech Republic to train our operators, but right now we have possibility to send here. It's different type of robot, but if you know can work with one, so but a big challenge to start to work with one. And smart products, yeah, what I mentioned in the beginning, it's not only product, but smart products, so we are developing like intelligent office, and we can track occupational tables, for example, in maybe in New York, it's like real estate very high price, and office, yeah, you should lease this, so you can track how occupancy is your table, how many employees are working, because according to statistics, about 80%. If you have like 100% employee every day joining 80%, so it can be like 20% free. So that's it. What I would like to show, I think. Any questions? What do you have on this one?
Okay, thank you very much. Questions, please. Okay, I have one question about training. You talked about ERP, enterprise resource planning, trainings, AGV, automated driving vehicles. Is it possible to find these trainings in Lithuania or region, Lithuania, Latvia, Poland maybe, or you are going to Western world, Sweden, Germany, and other countries which are more familiar, because it's very new things for us to, when we talk about ERP, everybody talks about ERP, but how to learn to use this software?
Actually, ERP we are using IFS. It's not so popular in this region, but in Scandinavian world we can find. So this one's training how to use. We was using this program for 6-7 years, something like that. But when we start to connect our machines to this one, so it will be a little bit challenge. So what we did, owners or hire one person who was working in this one for development. I mean, like for Microsoft. So we will take one person. So he has help for us to develop like by itself platform. And training is selected from Lithuania companies, key person that they will prepare education material. Very trained on this one basic knowledge and spread out. So I have engineering training, robot integration training. I was done by myself on this one. So it's not possible to find in the market this one because it's quite unique. And even last year I have been in Germany in some automotive industry. Like Bosch, it's multi-million companies, and they say that. It's growing up IT departments only like for training, for cooperation and so on. So it's we cannot go and buy it, okay, I need training, please train me. You should you buy it yourself.
I guess this is a bottleneck of how this knowledge can be obtained about these new things which should be in industry 4.0, and in Western world is available. In our world it's not. We are starting to teach people how to program in industrial world, but it's only a small part of industry 4.0 concept.
Yeah, it's a bottleneck, but yes, you can accept this one slide here, that we have winners here with high qualification, well paid and so on, and this one is challenge, yeah, what you do with this one. It's like a practice success.
What was your previous ERP system before the one you use now?
It's the same. You have like Windows on your computer, yeah, and you would like to have control of everything. We didn't, some companies are doing like the same mistake here. For warehouse I have one program, for robotic another, so I have 6 screens on here only, and they can in. So our goal is like to have this one, but to adapt to our process. So and what is like secret here is our EFS here, it's called this one, enterprise system. We developed together with some partners like automation and integration server, this one translator. Because robots speak in one language, AGV this one in another, we have another protocol, safety system different, so we should have a translator who can integrate in this one. Instead to have you can count like one system, 2, 3, 4, 5, 6, so nobody can drive and so on. So this one, our ERP system is adapt, a little bit modification with that to our needs.
You said you have specific knowledge you are giving to your staff. What do you do about problem they are learning and moving away?
It's like social responsibility for companies to create like a company that they would like to stay here. So I could say that we don't have this one problem on this one yet, but you should act. You cannot like train and doesn't give anything for your employees. Both sides must cannot be like, okay, our percentage of changing, last year, if I remember, it was 10 or 12% of this one is manufacturing. So when we have 450 employees, 70 is in white collar, 380 is in blue collar, and like in Lithuania, it's very good like result. 10 or 12, I don't remember actual percent. Even like Thermo Fisher, who is from Lithuania, knows this one company, Bioscience, last year we had 8%. And we have 90% of bachelor's, master's degrees, something like that. So for what is this one good result? Yeah. You should grow up like a company.
Very good. More questions? Okay, thank you, Justinas, for your very interesting presentation. Our next presenter is Šiauliai from Joint Small Company Problema, and she will give a presentation and we will see
Okay, hello everyone. So, my name is Ashra and I'm here to represent our company, Lorima. Lorima is a small-sized company and at the moment we are at the stage of modernizing it, and I'm here to share our experience. So, Lorima is a screen printing company, so we offer enhanced design and we are producing heat transfers, temporary tattoos, water slide decals and vinyl stickers. So we have more than 18 years experience in printing service and we have 40 employees spread throughout 4 departments, which is heat transfer production, decal production, R&D, and business development group. So our company is working with local brands. Our heat transfer group works with companies like Odimas, Utenos Tricotages, and also we are proud in partnership with well-known European brands such like Emporium Armani and many others. And our decal department works with Baltic players, but also we work with other European companies such as Trek bikes, Giant, and again many others. So for those who don't know what is screen printing, a screen printing technique dates back to 900 before Christ, and it was maybe the very first technique to do the mass printing. So the screen printing is performed by transferring the ink through a mesh, which is partly made impermeable to the ink, so the squeegee or a blade moves through the stencil, and initially it fills the apertures of the mesh, and on the reverse stroke it forces the stencil to transfer the ink onto the substrate. So it sounds very simple, but we have quite a lot of processes if we want to make mass production. So we have to prepare stencils, and plus a single stencil making one color. So if we want to create a multicolor design, so we need each color needs own stencil. So what we have to do, initially we prepare stencils by using UV sensitive emulsions, and so we have to create the image using image setters, and we transfer the image using UV light. After we water jet wash the stencils, and this is how this is how we begin to create our designs. So, and this is where we started when we were 18 years ago, and at the very last 5 years our company started growing vastly, and it urged for changes. So we had to do something about it in order to be competitive. So modernization versus automation, those two concepts often considered as one and the same, but actually they are not. Like in our case, automation would mean replacing all our legacy printing equipment with state-of-the-art automated ones. However, by doing so, we would be at risk to lose uniqueness of our product. For example, but as I told you before, we work with fashion industry, and fashion is changing vastly. So, and designers have all crazy ideas. They want 3D effects, they want reflective, they want holographic, and if we fully automate the process, we would have to transition from fashion to workwear. So this is not the case. So initially we started implementing machines, and for example we bought adhesive powder adhesive applicator. So we loaded up with adhesive, yes, and we tried to implement into our production. However, it took us, because we have to change the materials based on our client needs and designs. So at the end of the day, we discovered that we can't use a single adhesive, and to run this machine constantly and to replace the adhesive, it takes such a long time. So we decided to get rid of it. So now we went the route that we started creating our own modern version of equipment. And for example, with this adhesive machine, we have plans to create a cassette that we could swap in this machine, and that would make our life easier, and we don't need that very up-to-date and modern equipment to do so. So what it gives, modernizing the equipment, it gives to us that less maintenance challenges, because our now legacy printing machines, they need lots of maintenance, and we have to have external equipment for spare parts, because they're now very outdated. And also we have issues with the tribal knowledge, that we have very experienced personnel that knows a lot about the machines, and if we want to employ young people, and it is very hard to share and pass the experience. So yes, the automation will solve the problem, but also it gives us some implications in creating our unique products, and so at the end of the day, so we decided to modernize the company and went the route that we had to upgrade. We are planning to upgrade multiple technologies. So firstly, I have implemented a testing laboratory where we test quality of our products, and one of our biggest clients kindly agreed to share their methods and experience in testing of what slide equals. Also, we have implemented claim monitoring system, which by monitoring and addressing the claims, we reduce our defective items by 30%. By implementing computerized production scheduling system, again we managed to increase our profit by 60%. So it's still done on Excel spreadsheets, but our aim is to implement a software. So at the moment we're working with one of local companies, IT companies, which are developing a customized software for us, so that would cover all departments and would help us to plan our work better, and we hope we'll grow as big as Roll.gun. We are using your desk at the moment, so I hope that will help us to grow and to generate more modern ideas. Okay, thank you.
Thank you. Any questions? I will ask see something how Raymond related to our project. I was 2.5 years ago to your company, and I remember young people which are very enthusiastic. I saw the carbon frame of track bike, and we very proud that we make. I don't remember exactly what it is, but we are only few companies in the world are able to make stickers on the carbon frame. We hope that it's very unique.
Yes, we don't have many competitors in Lithuania. I think we don't have none, but we have in other countries, and we struggle to work with our new products and to meet today's market requirements, especially for the carbon decals, when most of the inks are designed to adhere at high temperatures, and we had experience working with bicycle frames, which is metal, and it's much easier to propagate a product when it's heats cured under the high temperature. And carbon, it was our challenge, because we had to find an ink who would adhere to at a low temperature, because we cannot heat carbon frames. So yes, this is a project we are proud of, that we sort of our novelty. So, but we are nowadays more companies want to save cost and energy, so they are trying to transition from the ovens and to get rid of ovens in their companies and to go to lower temperatures. So they have more challenges now to find inks that would adhere to metal frames at low temperature. So it's never easy.
And co-founder of this company, Dominikas Kasparas, attended our training courses, and we bought CNC machine recently and going to do some stamps, metal stamps for making, I don't know.
Yeah, we would like to implement embossing technique. I don't know how to explain when you can on the T-shirt there is like a relief. So yeah, so this is why we bought the milk. Is it milk? So just to make like frames for our equipment. There's a sort of fashion and science in one.
Okay, thank you very much. Let's make again applause. Now we are going to our science part. We have two presentations from Lietuvos University. Sergei Sots will give a presentation about high-speed steel functionality gradient coating by laser cladding. We saw it at Lietuvos University. It was very interesting. And you will listen.
Hello to everyone, my name is Šiauliai. I'm from Lietuvos University and I present our study work which was done using our robotic system. So this research was focused on the improvement of surface properties of tool steels by means of laser cladding with powders. So coaxial laser cladding is one of the newest processes which is becoming more popular for surface treatment and which also is being applied in the rapid manufacturing industry. This process advantages high accuracy and local surface treatment, strong metallurgical bonding and very dense coatings, low heat input resulting in a small heat affected zone, slight heat deformation of cladded components, minimal dilution with the base material, high heating and cooling rate, resulting in a fine microstructure. Due to a number of advantages, laser cladding provides possibility to extend lifetime of expensive machine components and tools like turbines, engines, sheet metal, forming and cutting tools by means of refurbishment and repair. Meanwhile, despite of process positive points, the producing of qualitative coatings of tool steels by means of tool steels for cold and especially for hot press working is still problematic because tool steels are being considered as hardly suitable for welding due to high content of carbon and alloying elements. Frequent defects are pores, cracks and exfoliations of coatings. So this study was focused to the assurance of high durability of hard coatings by applying of keyhole mode laser cladding method. The hypothesis of this research was that applying of first layer of coatings onto steel substrate using keyhole mode laser cladding enable to achieving smooth gradient of properties in the coating substrate system using the similar steels. So. Naturally, residual stresses are appearing on the coating substrate system, which considerably decrease the properties of the coatings. So to solve this problem, it's necessary to approximate the properties of the coating and the base material. By this reason, it was offered the new one method. So experimental work was carried out using precise laser cladding system, which consists of industrial robot cooker and 1 kilowatt Etherium fiber laser. Experimental coatings were created on tool steel substrate D2 using high-speed powder M2. The properties of created coatings were evaluated in course of comparative analysis by examination of morphology of coating cross sections, elemental composition, micro-hardness distribution inside coatings, and tribological tests. So two types of coatings were created with major difference in energy intensity. during examination of coating cross sections by electron microscopy, it was noticed that reduced coatings had good metallurgical bonding with the base material. No exfoliations were found. These figures present cross-sectional views with reference measurements and conditional separated zones for coating substrate system. So these zones are marked in the following way: flat layer or flat zone, flat layer, flat zone, interface zone, and base material. And then the second group coating, flat zone, interface zone, and keyhole penetration zone, which consists of lighter and deep melting pools. So the thickness of the flat zone was measured excluding surface waviness, which means maximal finish and thickness of the coating. So this value for the first group coating was about 700 micrometers, and for the second group coatings about 400 micrometers respectively. The depth of penetration was significantly larger in case of second group coatings because of deep melting peculiar to the keyhole mold. The examination of microstructure of both coating groups showed a mixture of cellular and dendritic solidification grain structures. The mixture of grain in clad zone was aqueous, which corresponds to the homogeneous temperature field in all the directions. In areas near to the substrate, the microstructure has larger proportion of columnar dendrites, which grow in direction from the fusion line to the middle of the flattened beads. Comparing these two coating groups, the final scale of grainesses corresponds to the first version coatings, which approve also hardness tests. And first of all, it can be associated with the lower heat input due to the action of the focused laser beam, and as a result, higher level of solidification was achieved. So on higher magnification, globular secondary carbides can be seen. This white globe. This structures is typical for annealed high-speed steels. So the metal composition tests. In first group coatings, content of alloying element was was virtually the same as in original powder composition. However, second group coating content of molybdenum, wolfram, and vanadium in clad zone was significantly decreased and separates a larger amount of chromium and ferrium because of deep melting of the base material, and as a result, higher level of interdiffusion was achieved. So the analysis of microhardness distribution for both coating groups showed that difference in laser-cladding methods had significant influence on the coating properties. These 3D graphs of microhardness distribution for both coating groups demonstrates microhardness distribution inside the coatings according to the average value of 5 layers measurements. So as it is seen, the first reporting demonstrates a fairly uniform order of various distribution along the overlap and direction of cladding. Its axis. However, abrupt transition of properties along the depth y-axis is evident. In its turn, the second group coatings displays heterogeneity of properties along the x and y-axis. This applicable is of increased microhardness, which apparently corresponds to the cavities between contiguous keyholes. Obviously, to exclude this unfavorable peaks, the smallest value of overlap ratio should be used. By comparing both through depth distribution profiles of microhardness between produced coatings, it is seen that the smooth transition of properties for the second group coatings was obtained, considering that hardness correlates to the strength of the material, so the similar gradient can be inherent to the internal stress distribution inside the coatings. As it is well known, high hardness is often not the dominant factor to ensure best tribological tests. Therefore, tribological analysis was fulfilled to define coefficients of friction and their distribution along the tests. So, average value of coefficients of 3 tests for both coating groups were very close, which was about 0.5. And the little difference was for the second group coatings in running stage. Examination of form text by means of profilometry revealed that wear of the coatings actually was absent. In both cases, some portion of material from underbody was adhered to the tested surface. It means the positive depth of wear tracks was found. However, base material was less wear resistant than the coatings. So to summarize, also coating with keyhole mode in penetration had lower hardness of flat layer due to larger amount of dilution. The smooth transition of properties in interface can be obtained. Despite the significant difference in hardness, both coatings demonstrate very similar tribological properties. Through the peculiarities of keyhole mode, laser cladding, punctually graded structure of coatings, can be achieved. The properties of interlayer, which is intended to bond the similar steels, provide keyhole penetration zone. This in turn can decrease the gradient of through deadly residual stresses generated when materials with different properties are used. Thank you for attention.
Thank you, Sergei. Do you have any questions about high-level scientific presentation?
Did you analyze what mechanical properties of wire and what influence on the developing and fatigue of processes of a new device? At present, hardness is optical gauge, but its mechanical properties like firmness, strength, cooling, and so on.
No, in this study was analyzed from mechanical properties. We analyzed only hardness and coefficient of friction. So this is next step of our research to analyze also the another properties of these coatings. That it was only the first step to analyze these methods.
More questions? Okay, I want to add one thing. We have good experts in coating, which are also, as I know, very interesting topic for industry to review materials which is wearing off. We have experts, partners at Tarptautinė University who are interested and contact them and do some applied research or research. Okay, thank you, Sergei, for your presentation. Next presenter is also from University. This is Guntis Pingis, who will talk about wear calculation in slide fixing pairs. So much as
Hello, dear colleagues and students. For those who were on Tuesday these short seminars, I tried to explain a little bit about wear processes, and I said that there are a couple, I showed already that there are a couple of wear types, and each wear type actually needs a deeper understanding how it is processed, how we can influence it, how we can predict it, and also how we can deal with this process in order to make this process controllable. For today, I will try to explain a little bit about wear calculation models, ways which are known already and which historically developed, and I will try to shortly explain what are the advantages and disadvantages of these calculations, so to say, these models, how to predict the process of wear. So let's start with the first calculation model, which is closely connected with probability theory, and using this equation we can predict the fitting service life. So we cannot calculate the wear amount, we only can predict the period of this life after the damage will occur. So you can see that this equation is relatively simple, and its positive side of this and the negative side is that it is not connected with factors which affect directly the component operation. I mean physical or mechanical properties of components such as load, velocity, and so on. And also one of the parameters which are involved in this equation must be found before when we carry out researches. So it must be already known. And this is also one of the problems that we must know this parameter before we predict the life of this heating. The second model is closely connected with classical laws of physics, and it is connected with interaction of contacting surfaces, atoms, and following separation of these atoms. So, also quite a simple equation. You see that here we involve hardness of material, in this case according to Dino, and parameter Z is probability of atom separation from the surface. In case it comes in contact with another atom from another counter body, let's say. And also law affecting these components. Also this equation is not connected with parameters which simple engineer could take out from the literature and put it into a formula and try to predict the heating life period. The third calculation model is more closely connected with say, more simple parameters, and it involves pressure of friction pairs and relative gliding or sliding movement speed. So you can see that here we also have, here we already have such parameters, number of rotations, loading effect components, but we also have such parameters as T1 and T2, which are determined only in the course of long-term experiment. So, what is the use of this equation if we need to make the experiment, long-term experiment? So we can state after the experiment, actual heating life, without using this equation for calculations. So this is a great minus of this attitude of calculation. The fourth calculation model already includes the characteristic sizes of the friction pair, also physical and mechanical parameters of these friction component materials, and surface geometrical parameters. But as I will explain further, you can see that speaking about surface geometry, these parameters, so-called base surface coefficients, are not standard roughness parameters. So we must calculate them using special coefficients, which is not appropriate nowadays actually, because we have standard for surface roughness parameters, and we will use whatever standardized parameters. And continuing, I would like to introduce the fifth calculation model of which I'm working still. This model, in addition to the above mentioned fourth model, actually takes into consideration 3D surface roughness values according to standard. We model the surface micro photography, so to say, with random field theory, and we explain the where with the use of category theory. Actually, this is only the beginning of equation. It's quite a simple general one, and under each of these letters is hidden a great amount of formulas, equations, which shows with the help of which we try to use math, physics, and different fields of science, and try to explain how the process is going on and how to calculate it. Of course, in order to explain all these equations, it will be necessary at least 2 or 3 hours, and we are not going to do this. I will show only you. So, yes, here you can see the surface contact and the wear process, which is divided into 3 parts. First part is running in part, the second is normal wear, and the third is disastrous wear. Actually, what I'm doing, I'm dealing with this second part, which is normal wear, and because the first and the second, the third part, actually it takes only a little percentage of the whole period's life. And so, what is necessary to calculate, according to our theory, what is necessary for simple engineer to take, which parameters are involved here. So, here you can see the kinematic characteristic sizes like nominal area, like load, like slide movement, speeds, velocity, and so on. Here we can also involve characteristics of friction component fatigue. It's like a friction coefficient, like parameters of material fatigue destruction. After that, we state the surface roughness parameters, initial wear and corresponding time for initial wear, and allowed wear. We can calculate using this allowed wear of normal operation period and also of maximal wear period. As you can see, these 2 stages, maximal wear is calculated as this normal period and running in period also. So, carrying out all the necessary operations and a huge amount of different equations, we can get the last equation for wear calculation. You can see it's quite simple, rather simple, I would say, not so, but anyway. And you can see that what is involved in this equation. So, constructed kinematic characteristics quantities like rated area for subject, load, movement time, sliding speed, and so on. Fatigue friction parameters. Yes, and one more thing is friction coefficient or coefficient of friction for this equation must be less than 0.1. It's the main so to say statement for this equation to work. And the parameters which must be stated after running in period, they are surface, of course, surface roughness parameters, which are already 3D parameters. Initial wear period and the corresponding time of this period actually also must state it using a short experiment, not for the whole heating life. and limiting wear. You must know in order to calculate the ticket's lifetime. Coming to the conclusions very quickly. So, what is the aim of my work, my team, is to make the question, which is quite easy for engineer to take it, to choose the necessary data, to know all the other parameters, and to make these calculations. So, as you see, this theory is based from several, combined from several branches, so to say, using standardized 3D roughness parameters. We take into account materials' physical and mechanical characteristics, and as I said, we explore the wear process, taking into account definite serious conditions of sliding friction pairs. So, I think, I hope also, that this work will be of great value for predicting service life for different surfaces. Mostly we're dealing, of course, with metallic surfaces, and there will be no use of long-term experiments and quite expensive experiments, I would like to say also. So, this is quite shortly, of course, because as I said, to explain all the equations, it's necessary for time tested for a couple of hours. If somebody will be interested in this area, I also have quite a lot of publications which I will share. I can share with those who are interested, and to make further cooperation. So, thank you.
Thank you. Any questions? Okay, Simon, that is great that the training is being supported by scientific research about wear processes. And good luck in your research.
Thank you.
Now, Simona Bukantaitė is coming for his presentation. She is our master student, and I'm very glad that she made presentations at Lithuanian Science Council, or I don't know how to say it in English, and she won some awards. Maybe she will tell about more about it.
Hello, my name is Simona Bukantaitė, and as said, I'm from Šiauliai University, and now I'm studying mechanical engineering, and this is my final year of master's studies. Today I will shortly present my research, and it is effectiveness study of bicycle factory process modernization. My research object is shot blasting process, and the aim of this research is to evaluate if optimization is possible with the current situation in factory. And of course, I need to find the best solution, what we need to select to optimize our factory. All calculations are based on real data from factory, and the data is up to date. And in my research will be two possible ways: one fully robotic, and second partly robotic line. And also I will analyze the current situation and do the evaluation and calculation of when this investment could give profit. As I said, all data is from factory, and it's the newest data, so my research could be a strong base for factory modernization. As we all know, in 18th century, industrial revolution started, and now we are in the fourth, and this one leads us to robotic systems which could be connected one to each other without as small as possible human impact. So robotization is almost here, and companies need to produce more since there are consumption of growth, and we need to think about robotization. In my analyzed factory, the main labor is the human, and this causes more and more problems since it's hard to find good employees. You need to teach them, they get tired, they get sick, they make mistakes, and also increasing the minimum wage leads to bigger costs for the company. In this slide you can see how during last financial years my research company grew the number of employees, and it was almost 63% of growth. Now about the process which will be analyzed. The shot blasting is located in the preparation unit, and it must be done for all raw parts which come to the factory. Mostly all of the components come from Far East, and that means it takes 4 or 5 months by ship or train to get to Lithuania to our factory. That means that all of the parts get affected by corrosion, and this could be avoided if a manufacturer in the Far East could protect them by phosphating or anodizing, but in China there are restrictions because air pollution is very high, so we receive parts as we receive, and we need to have shot blasting process. In this factory we have our own paint shop, and it's important to understand that all parts, all surface need to be cleaned, because we could not paint the parts which are rusted. And this is the workplace of my investigative process, and during these financial years the factory plans to produce 300,000 bicycles. That means 1,000 per day, and every bike has one or more parts which need to be painted. Small parts are oiled, so you need only to wash them, but big parts such frames, forks or carriers need to go through this operation, and that's we sum up to 2,000 pieces per 8 working hours. And how does this work? Well, you have parts, one employee unboxes them, put on the rack, then push to the machine, and then other employees, after the process, take each part one by one, shake them, because my mentioned parts, frames, forks, and carriers have tubes, and of course metal balls get into tubes, and you need to clean correctly, not to leave metal balls inside. Because if you leave metal balls during painting process, you will pollute the camera of painting, and of course your surface will be damaged, and to rework this increase costs of painting. I have made professional risk identification factors and see if everything is acceptable in this process, and I found out that lighting is not enough, but also there are 2 big loads for workers on the upper part of the body, but this is not normal, but this is logical, because workers need to shake 2-3 kilos of metal parts every minute, 8 hours. So of course this is not good for physical health. Also, this operation is loud, and due to metal balls on floors, it's also slippery and could cause damage. Nowadays, the modern technologies led to simulate future factories with some kind of programs, and my program is Visual Components, and with this program I mentioned 2 possibilities, fully and partly robotic lines. Firstly, robot-human modernization. That means we will have one employee, and others will be changed by the robot. This we could see costs of this modernization, and this we could see how it would look like after it. We could see one person who is unpacking boxes, putting parts on the rack, and the robot would do the hardest part, shake the parts. Also, as we can see, this kind of simulations let you to avoid mistakes and also to implement lean systems, because you could avoid unnecessary places and do in the developing stage the best result. Second modernization is robot-robot, and this of course is almost twice expensive, but this modernization would lead to fully robotic line without any human. Racks would be transferred on the conveyors, and we could see that both robots would work without any interference from the human. So this could look like the new process. And in these tables we could see calculations how much factory pay now and how much we could pay with these two modernizations after 10, 15 or 20 years. And in the second table we could see the benefit, and we could see that in all 10, 15 or 20 years more beneficial is the robot human, and after 10 years we could save more than 200,000 euros. But these modernizations, for example, robot human would do benefit after 59 months, and second one would do after 83 months. So you need to wait to get some kind of benefit. So thank you for the attention.
Thank you. Any questions? So I'm happy that you are using the software purchased in the project for your research, and I know that you are doing PhD studies to study as a PhD student and to extend your research is related to your bicycle company. Simone is working at a bicycle company. Latvian team were yesterday, and it's most modern company of bicycle production, I think, in Europe.
Okay. We studied that much.
Okay, thank you. Now, I'm inviting Tomas Kaučikas from joint stock company ATC Baltic to talk about prospects of robotization in our regions, Lithuania and Latvia.
Okay, so once again, hello, my name is Tomas Kaučikas and I'm from company ATC Baltic. So first of all, I would like to thank you to Gediminas for such a nice invitation, for such a nice meeting. It's very pleasure to come back to this facilities again because I graduate here, and let's say I'm from Šiauliai, my native town. I live near Baltic Virus factory, yes, so it's, let's say, my town. Yeah, so I would like to speak shortly, briefly, if it's possible, of course, about the future or perspectives of our business, what is happening in Lithuanian and Latvian market. And first of all, I would like to introduce by myself, yes, so about my company. So, company ATC Baltic is founded in 2008 with high skill metal proceeding and welding business. So there is we are two founders. Aurelius, my colleague, we were graduating in the same Šiauliai University, mechanical engineering. So for today we do have 12 employees. We are working in two branches. Let's say our market where we are dealing is Lithuanian, let's say 3 Baltic countries. And Latvia is very important for me personally. Let's say basically it's like a domestic market. And in Latvia we are dealing almost half of business. So what we are doing, let's say what our company is offering. Yes, so first of all we are system integrators, robotic system integrators, and mainly we're using OTC Daikin, Japanese company robots. So we're making full installations, full maintenance and service. Also we are dealing in manual welding machines, and I would say in more high-ended welding machines. So also we are doing automatic and high-ending solutions for technology for the industry, handling and palletizing robot systems, industrial microscope assembling tools and grinding tools as well. Also we are supplying our customers with the toggle clamps for jigging masterpieces and for robotic systems and for CNC machines. Also we are working with company Esta, who is basically also there. It's a German company who are one of the leaders in a workshop cleaning facility, let's say equipment. Also we're dealing with Japanese Kyogiken. This is a high-end spot welding tables. Also one of our customers is in Šiauliai. And we're dealing with some consumables and other materials which is necessary for metal industry and so on. So what also, if we are talking about Latvia, so I need to come to this point here. So who is connecting our companies? In Lithuania there is a company Limpra, so probably everybody knows. Maybe Latvian knows, not. And also in Latvian market there is a Mechanical Engineering Association, MASOS. Yeah, so those both two associations is working in different type of way. MASOS is a little bit more closer to the small and medium business, and Limpra, unfortunately, they are working with the higher and bigger business. Yeah, so I don't know what is better for every market, but such a system exists. Yeah, so there's a short introduction about welding robots. Yeah, so if come very briefly here. So there is first robots for welding application was done in 1954. Yeah, so there is step by step. You can see what is important for me. It's that OTC they have been started their business in North America in '79, and for nowadays it is one of the biggest welding robot producers in the world. Yeah, so that will come later. So this is one of the first robots, welding robots, which is basically still usable in some of our markets in Europe. The name of that robot was Thor. So nowadays it's very close to that robot type is very close to nowadays robot. Yeah, so that's why we are speaking about. Yeah. So also I would like to introduce a bit robotic market. That is IPR, robotic World Robot, let's say, association or institution who are trying to calculate how many robots we do have. Yeah, so some estimation and then facts. Yeah, so we can see that in 2017 still automotive industry is very important. Yes, electrical and electronics is the second market in the world. Yes, And what is very interesting that for metal and machinery, robots is still and growing quite a lot, yes. Also, plastic and chemical products, food industry, some other and unspecified. What is estimation? Yes, so in 2017, robot sales increased in 30%. Yes, so it's quite huge amount. Yes, and for nowadays, in 2017, it's the last figures what I found. Yes, so it is almost 400,000 units per year. So it's quite a lot. Yes. You can see, yes, how those robots are spread in the world by the columns, yes. So blue color is Asia and Australia, red color is Europe, and what is interesting that America is little bit has less than Europe market, yes. But here probably is calculated both Americas. And what is the future for the robots? Yeah, so in 2017, basically, when I was preparing for this meeting, yes, there was very interesting, yes, but they were showing the growth something a little bit more than 15% to, let's say, in 2017 and 2018. But factory, basically, that increase was almost a fact, yes, so it became a fact. 15% every year, yes, so they have calculated, yes, in 2021 that increase will be quite dramatic. So how it is spread in Europe? Yes, so I would like to be in that, let's say, our countries, Lithuania, Latvia, and Estonia as well. I would like to put in that mark that is Central and Eastern Europe, but probably this is not true. Yeah, so we should be the lowest that line. There is unspecified line. Yes, so let's say there is some small fact that only 2 robots is coming for 10,000 workers in our in Lithuanian market. So in Latvia it might be a little bit more, but figure it's quite close to that. So as you can see, Germany is one of the leading users who are using, let's say, mostly of robots. Here in Central and Eastern Europe, you can see very huge growth of 28%. So here there is probably in that Central Europe is coming countries like Slovenia, Slovakia, Czech Republic, and in our internal meetings when we do have let's say discussions with our integrators, so we see also some kind of figures. Basically, those countries they are growing very fast and in huge amounts, yes. And let's say such companies like Toyota, like Hyundai, yes, they have opened their factories in Slovakia and in Czech Republic, yes, and as well OTC Daikin, my partner, they have opened their own factory in Slovenia. So this part of Europe is still growing quite a lot. So if to come back to automatic welding process and to compare what was in 2010 and 2015, yeah, so what kind of process basically I used. So 47% is for arc welding, yes, in 2010, and in 2015 basically the same mark, but 2% of difference is for laser welding. So laser welding is quite huge growth, and what we can see that spot welding process is going a little bit less application because lasers are quite and arc welding processes where, let's say, they are improving quite a lot. So, who is the main market players in Baltic countries? Yes, so I should mention those companies: ABB, Kloss, Kawasaki, Komau, Fanuk, Yaskawa, IGM, Kawasaki, Kuka, Nachi, OTC Daihin, and Šiauliai is one of those key players, let's say, in that still small market, yes. And especially last year was very huge, big competition appeared, yes, yeah, so let's say we are facing to that quite a lot. If to shortly to introduce why we have chosen OTC, yes, why OTC is very important for me, so it's very shortly to explain you that OTC is in a Japanese market, it's named Daihen. It's basically the same name, OTC Daihen. Yeah, so we can see that it's worldwide number 4, that 8% of the total welding machine market. Yes, I mean welding machine like welding units itself, and the arc and cutting robots, it takes 29%. Yes, so it's a huge amount of the market. And they are producing in welding machines and robot itself, let's say, from one hand. So it's for me, it's very easy to integrate everything, and it's working quite well. It gives quite very nice result to our customers, what is most important for everyone, and for me and for my customers. So here I would like to show let's say very briefly, typical or standard robotic welding cells, let's say, which can be built with a smaller robot, bigger robot, one type, other type, one type machine or other type. So there is quite huge of modifications possible. Yes, so there is 2 working stations without any moving turning tables. So here there is basically very similar application, just with rotating table, yes, which gives more flexibility with robot reaching points. So again, with very short, with a small working area, but with a rotating masterpiece. Fourth example, it is most probably usable, or maybe more effective usable working station, where robot can reach, basically it can do almost 90% of every kind of application. The fifth example, yes, so there is the robot is combined with 2-axis positioner, so we are calling such a systems 8-axis systems. Yeah, so it's has much more possibilities to do work. And again, it's one of it becoming a typical of example when a robot moving from on a slider, yes, from one station to another station, and then in every station, the robot can be tilted or can be turned, let's say, to one axis or to 2, or sometimes even 3 axes. Here is, let's say, the same similar, very similar application, which is all, let's say, which was done already. Then the robot is working on a huge slider, yes, so this is a special design, and then it's becoming a standard cell. When one part of the working area is not moving, not using any kind of axis, yeah, and another working area is using 1 or 2 axes under customer needs, yes. Well, it's a standard, basically, that there is no any standard cells. It's only typical cells, I would say, yes. And every customer, they need, they do have their special needs, special understanding, and special trying to think over about a special design which can cover as much work as possible. Yeah, so this is one of the example of let's say together with the customer made a cell, yes, for today only on the paper, but probably become a real model. Yes, so there is three working stations. Yes, small slider. One part, let's say, if customer would like to use small, or he needs to do or to produce small masterpieces, so he can use 2 working stations. And if he needs to produce a huge, so he removes one of some positioners, so we can rotate big masterpiece. Yes. Again, so here it is not a standard cell, but let's say it's a real project where we built it 3 working together robots in a one huge station. It's almost more than 300 square meters of area, yes, which is combined everything from one operating panel, which let's say, and also the system is working integrated with other lines of the factory, and then that's basically everything is in the full automatic way mode working. Yeah. If to come to that realistic point of view, yes, we need to go over the very many steps. So here of that project, the first of ideas, what was thinking about how to improve or to solve the problem to the customer, yes, and to start the production in more effective way. Yeah, so this is one of the probably 20 of designs which was made for that customer. Also, here is another example, yes, what we already did, yes, so this is huge and big robot. It's integrated together with a press brake machine, old press brake machine what customer has, yes, and it's working also. Let's say this machine is doing basically 3-man work. Before this application, our customer was using 3 operators to do the same job for that. Yes, there is not very. This application is not very. It's not so. Doesn't have so big speed, but it's very constant. So basically, they are doing. Robot is doing the same job of 3 people over the 2 shifts. I mean, it can be, every robot can be combined to bending machine, punch presses machine to bring or take out the masterpiece and so on. Just, you know, it should be think over about every application, yes. And yeah, it's not easy job to do that, but on the other hand, for some customers, it's no there is any possibility, yes, to do.
Excuse me, what is an approximate price for such kind of robot within the landscape?
You mean without implementing?
With implementing.
It's very dependable. It's very dependable, yes. So you can do. Okay, I can tell you only what the fact yes was, but it's not. Let's say for that application was over the 100,000 euros, yes. And but customer was lucky that we found the needed robot. What was let's say was with a discountable price, and also some other. And as in every project, there is some tricky point, let's say, yes. And we spent too many hours for that application what we were expecting to spend, yes. And but on the other hand, there is nothing to do. Customer was lucky. and still they are really satisfied. And that system, let's say, it paid back in 7 months. It's truly calculated on a paper without any, let's say, spreadsheets or and so on. Let's say it's
expensive ones, 3 employees.
Yeah. Now it is, let's say, it's that system is working, with this system is working one operator. He is not very skilled so much, but he was working on the same application before that in the manual. Now he's an operator for the robot, yes. Here is again of one of our projects in Latvia, company Brabantia Latvia is one of our key customers, yes, so which to whom we have made the we have integrated the full packing line, yes, who also, they do have our welding robots as well, and here it is fully integrated packing line and packing process on a Euro pallet, and which can bring, let's say, operator can bring to the stock, yes, for dispatching projects. Also, let's say, I would like to show some very complicated production, let's say, or production of the products. Yeah, so to shortly explain, unfortunately, the sun is shining too much. Yeah, but here it is used using 7-axis robots, a new type of robots, and 4 pieces for one masterpiece. Yes, to welding exhaust pipe for some kind of vehicle. Here also the Truth project in Germany. Yes, a very complicated. There it's necessary to customers producing the heat exchangers, and it's in both ends. There is a full of small diameter of pipes. Yes, and 4 robots. 2 robots in each side. There, let's say, one robot is welding and another robot is feeding the wire. Yes, and it's very, very interesting and realistic project. What's new in our life, and what's will be very important for our customers? Yes, that well, that's why the 7-axis is better than 6. So it's a completely new welding robot generation is coming. It's already is in our market, and let's say additional 7-axis brings much more bigger possibility to our daylight work. Let's say in 7-axis sometimes can exchange 6-axis robots plus additional 1 or 2 axis. Yeah, so it brings to our operators higher and bigger flexibility to do their work and their task. Yes, because sometimes in a metal proceeding it's not enough to have 7-axis. Yeah, so what we can see, basically from 4 kilogram of payload of robot till 20 kilogram of payload robot will already has a 7-axis model. Yes, so it's big improvement in our day life. What is additional tools, let's say, for which helps for our robot users or operators and so on? So there's sensors for arc and positioning of the masterpiece. Yes, calibrating tools and equipment, torch and service tool, offline programming software. So which I will talk a bit later. Wireless teaching pendant units, clamping jigs, process monitoring systems. So it's also those facts are, let's say, those tips are basically our facts, what is necessary for our market, what customers needs. Sometimes one or other, but basically, if to put everything, every customer needs the same items. What's else new? Yes, so this is OTC Daikin has launched or a new system which we are calling synchro feed process. It's basically, it's today our technology. What we can use every our customer, yes, so we can bring the very high speed without any status. It brings very nice arc characteristics, yes. Brings very low heat input to the every welding scene, yes, and then brings very high speed. Basically, what our customers they are speaking about, what's the speed, if they're asking what the speed is possible to weld with a robot, yeah. So, you know, physics is physics, yeah. It never lies, and but you can adapt to it. And nowadays, let's say, all West Europe, they are calculating 80 centimeter per minute welding speed, 1 meter, and some of them even more. So this high speed welding is something brings to that, to the high speed, and having less thermal distortions and deformations. Yes, so here is very important item. What is for today is what we are using already. Offline program, I would like to, so some Lithuanian language still left. So we are using, and our customers use two. We do have possibility to have two offline programs. So it is own Japanese product FDST called. Either we are using Delphi Arc or Delphi Mill and other of programs, yes. So what's the difference between those? First of all, interface, yes. Without any offline programs, basically what we can, I would say we can do nothing. Some many years ago, we were trying to use our skills to solve one or other problem, but time is changing, and task is getting not easier, but much more complicated. Yes, so here it was a build it some type of application or simulation under customer needs. Yes, where one robot is welding and another robot is grinding. Grinding is very difficult application. Yeah, it's not so easy. So we offer to our customers one of those our ideas. Yes, what is possible to do and how to do in a most fastest way. Yes, to having less time saving. Yeah. So. And then to go further, the Delphi is the process itself. It's much more brings life much more easier, yes, and it has much more possibility to use different of equipment. Yes, with FDST we can use 2-3 robots, not more. With the Delphi, which is based on a visual components basis, it's possible to use much more items. Yes, it's much more. It's possible to simulate basically the whole factory.
Yeah, also I could like to show that
it's a working project in Latvia and in Liepāja. Let's say without this kind of simulation, which is with that simulation, it's possible not only to simulate the production of the workshop, but it's possible to teach every robot. Yes, not only for welding, but also and for picking and place application, and then some others. Yes, so here it is very. Without that kind of simulation, we can do basically nothing. Yes. many of our customers, they are trying to be, or they are afraid, yes, of the teaching pendants, teaching box, yes. So if they are asking what kind of professional skills should have an operator, we are always saying, yes, operators should be with less of skills of welder skills, but he should be not afraid to use at least a mobile phone today, yes, smartphones. So here it is basically the same, yes. How it looks, the teaching pendant. It's very small tips. It's small tips, but very huge things in a day life. Yeah. So what we can do with our robots, we can set some thickness of material, some connection of the material, and the robot brings the truth and the fact parameters for the, let's say, brings for operator, but much easier or shorter time for program every process. Also, wireless teaching pendant, yes. It's very lightweight, yes. It's almost, it's less than 1.5 kilograms, yes. Long hours can be used, more than 5 hours, let's say. Has fast charging battery and charge as well. So basically, it's possible to work 8 hours without any stop, big stop for operating. Yeah. So and it's very big improvement. With the same one wireless teaching pendant, which can have its own application for every user, can be used for additional 5 of robots. Yeah. So it's also very important thing, yeah. Again, what is our customers, they are asking quite a lot to bring full solution, yes, to their under their needs, yes. So here it is a jig or a jig tool for holding the masterpiece for a welding application, yes. So you can see how it's quite complicated, yes. And for here, it's needed those kind of tubal clamps, which can be in pneumatical and hydraulic, yes, and let's say, and everything should be combined by someone, yes, and all problems should be solved by mechanical engineers, yes, by technical people, yes. Also, for every jigging tool should be necessary to have some special knowledge, yes. Also, very often customers are asking us what's assembling tolerance can be for masterpiece, yes. And every time, very often, our customers, they are doing mistakes, yes. They are thinking that some of the accuracy or disaccuracy, let's say, can compensate each other. No. It brings, let's say, to a huge amount, to suminės paklaidos kaip yra.
Sergejus žino.
Huh? Some tolerance, yes. Some tolerance is, let's say, if one masterpiece is non-tolerant, another one, so it cannot compensate. And sometimes our customers, they think over that if they put many of sensors on a robot, it can solve every problem. No, only human can solve that problem. First of all, task is to put in the right position and right geometry measurement masterpiece to the tool which is necessary. Yeah? So what is the requirement for MIG-MAG application? Total accurate needed about 0.5 or a half of the diameter of a wire diameter. Yeah? So if the customer is using 1.0 wire diameter, so it means tolerance can be, or a gap could be not more than 0.5 of millimeter. Yes? TIG application needs even much more higher. And here, 1.0 sometimes is not enough. Yeah, it's necessary. Robot should has the additional arc force measuring units on itself. Yes. Also, raw material control. It's very important thing. Also, some of our customers, they are going away from Eastern made steel and looking forward to German, let's say to West Europe produced steel, because it brings life much more easier and gives less trouble for not only for a final welding assembling, let's say, but in the processes before it. Yes. Also, jigging tool should be also quite accurate, and shouldn't be forgetting about the basis of the assembly masterpiece. Yes. And very often we receive too high expectations from the stuff to robotic system. Yes, that's what I was telling about, that we think that robot, it will solve every problem. No, only human can do it. Also, very often our customers, or trying to buying as cheap as possible, they're forgetting about the safety reasons. Yes. We are speaking about that with the customer quite a lot, and it's all the time. It's becoming like a proveness discussion. Yes, and so there is some very short, only few of the sentences which was found in newspapers. Yes, and we can see that in 1979 some, let's say, injuries or even worse things has happened. Yes, in 2015, sorry, it's in Lithuania, but in Volkswagen, one worker was killed, yeah, by a robot. And also in 2017, also somewhere in America, was also killed by a robot. Yes, so it's not a joke. Yes, and some of our customers, they think that it's possible to avoid, yes, and then saving quite a lot of money. Yeah, so bad examples. Those three upper pictures are from somewhere from Asia. Yeah, so there is a girl from bicycle. Yeah, so factory. Yes, so you can see how bicycle frames are made in Asia. Yes, and a good examples. Those first two pictures, they are one is in Lithuania, another one is in Latvia, and the third one is I cannot remember right now, but that is like a very good example. Yeah. Now do I have some time or? Yeah. You have to go. No, it's in Lithuanian, but try to translate, yes, and to speak about this. So very often customers think that it's necessary to have very high educated stuff. No, it's not a truth. In realistic, let's say, operator, it should still be an operator. Yes, he should have some understanding about the process, but anyway, it's necessary. Yes, so first of all, people should not be afraid of the robotic systems. Yes, some of our customers, they think that only the high volumes can be produced in robotic welding. No, it's not so true. Yes, high volumes brings bigger profitability. Yes. But on the other hand, for example, our customers, they're even programming and using the robots even for 10 or 5 pieces. Yes, just because of the nice look of a masterpiece, which is required by their customers. Yes. the third myth, yes, what customers they're expecting that robot will solve all assembling quality problems. No, not at all. You can do nothing, yes. If your accuracy of a masterpiece is not enough, yes, you cannot. You can put so many additional tools to track and for seam and track the masterpiece position, but it takes time, yes, and unfortunately we do not have it. Yeah, the fourth is combined to the first one, yes. Still, in every company should be the at least one or two high skilled welders, welding skilled people, personnel, and high skilled operation robot programming stuff. Yes, at least one or two persons. Yes, all other people can be just an operators who might do some kind of small adjustments and so on. Yes. Like the lady which was speaking before me, yes, so she puts the figures on the table, yes, so and it was very nice to see her calculation, yes, so here is the same idea, yes, that robotic systems, it's very expanding and brings very big time loss, let's say, or payback. Unfortunately, not unfortunately, if to calculate, for example, no any customer is buying for their future projects. Yes, they are buying for their today needs. And that it's necessary to understand. And many of our customers, they think over quite. They are looking forward to very huge future. Yes, no, we should think about the today our needs and only think about 5 or 10% about the future, yes. So that brings the life much more easier. So that's why there is a typical of the welding systems. But sometimes the customers they want to do as much as possible with the same unit. No, it's sometimes when you need to bring some heavy lorry, yeah, you are ordering the truck instead of bringing to your car, yes, and putting some additional trailer to that. So here is the same idea. Yeah, the main idea, also one bad thinking and myth that every piece is possible to weld with a robot if you are welding in a manual way. No, it's not so true, yes. Sometimes it's even better to use, instead of the robotic welding, to use some semi-automatic way, yes, using some semi-automatic items and equipment to do the same job instead of doing a welding application with a robot. Also, one of the myths is that robot cannot be used for a huge masterpiece welding. Yes, no, it's possible. Yes, but on the other hand, you need to. It's possible to put the robot on a gantry or 15, or like last week I received the inquiry from Latvia, even for 32 meters long rail, and it's possible to do that. But only thing what is necessary to think about is the total assembly accuracy. Yeah? But of course, everyone knows that it's not possible to, in such a long distance, to keep the same required accuracy. So here, other way will be not. There is no other way to not using the additional equipment of to the robot. Yes, I mean about the tracking and positioning system. So yes, so basically that myth is also not so true. So that's it. Thanks for your attention. Ačiū už dėmesį.
Thank you. Maybe one or two short questions.
Will you have some integrated solution for 3D cutting on the building application?
The 3D cutting? No, we did not, and I think we are not ready. Cutting with, you mean with a laser, yes? Plasma, it's okay. Yeah, plasma, it's, let's say, it's very standard process. Plasma, it's okay to cut pipes, sheets with a robot. There is, because it's a standard equipment for us. ODC is producing not only welding machines, but the plasma unit itself, which is very commonly used for CNC 3-axis cutting machines, yes? And also it can be used then for robot. And it also, let's say, it uses the power source like calculator. But with the laser, no, not yet, and I hope that we will not get such a kind of inquiry. Because it's very complicated. Yeah? First of all, about the safety reasons, and it's necessary to save, and one day maybe. For today, no. Plasma is very often, let's say, asked, but not every customer nowadays. You know, everyone wants to and needs to get high accurate masterpieces. So plasma, like a process, is not enough for cutting. With the plasma cutting, yes, of course. Yeah.
More questions? More? Okay, I should say that I'm very glad that ATC Baltic built for us our industrial robotics lab. We are very happy with the flexibility with the setup, and during workshops it's available to use it and to see how it works.
Yeah. Forgot to mention that here there is 2 hour robots with getting this already. So yes.
Okay, you will see it in the video. Okay, thank you, Thomas. Now I'm inviting Simonas Baltrimaitis. He is representative of one of our most advanced metal processing functions in the region. He is also one of the letters of our project. Please.
Okay, so hello everyone. Nice to see so many participants in this location. And first of all, I'd like to present myself. I am Simonas Baltrimaitis from Fortas company. I'm one of the employees of this company. And today I will introduce this, I will show you a short representation of this, and just to give a small picture of Fortas company and what Fortas is doing. What kind of production and what kind of equipment do we have. Okay, so in this slide you can see that Fortas is one of the most modern metal processing companies in Baltic states, established in 1994. We have 160 employees, high qualified, of course, necessary to mention that. And production area is 12,000 square meters. I'd like to mention that we last year started to build a new facility, which one we expected to be finished in next month. And most important, which I want to mention that we're exporting around 70% of our production and services. In this slide, you can see that our annual turnover from 2014, glad to see that it's proportional growing, and we're hoping and expecting next year it will also be growing quite fast. Small details about quality, let's say, about company. In this slide, I would like to mention 2 lines that we regularly training staff and also certificating them. Well, we send it to the trainings to certificate them. And honestly, to say that we are forced to do that because we all the time investing in new equipment and it's required to train the operators to just simply work with the new machines. Certifications, of course, it's necessary to mention that we keeping the quality in our services. As you can see, ISO 9001 and etc. Our customers, what kind of industries we looking forward. So most of them, let's say, to mention the forest, agricultural industry, food industry, medical, for example, and others. Supply. So, well, we cutting and we're producing from sheet metal. So it's necessary to mention that all suppliers are close to our warehouse. So it's not a big deal. Depends of customer request to get the material and make the required parts. Engineering and development department. So it's also necessary to mention that we have quite skilled engineers who are producing the parts, talks with the customers, shoulder by shoulder, just to reach the best result and the best price area. And of course, machinery, which one, well, it's necessary to show for the customers, just to explain that we are capable to make parts and fast and good quality. So necessary to mention that most of our equipment is Japanese made. Amada and Mazak, for example, and OTC. Two equipments I would like to show what kind of machines we have. For example, 3D laser machine made by Mazak. To mention, so 6-axis if I'm not lying, but yeah, it should be 6-axis. 2D lasers, we have 4 of them. 2 laser machines with a TO2 resonator, one with a fiber and the other one with the DL, the newest technology. It's a direct laser for the best and fastest cutting surface. 4 simple applications. We have guillotine machine, Amada, to put the sheet. Also we have bending machines, 6 of them. 4 of them is with a hydraulic unit and 2 of them is full electricity for accuracy. Welding, we have 18 manual welding workplaces, additional 2 welding robots and 3 contact weldings. We're offering TIG, MIG and MAG welding. Also necessary to mention that in short future we expecting to invest in additional 1 welding robot and also expand the manual welding workplaces. Machine tools, for the moment we have a few turning machines and 1 milling machine, but just to know that we invested last year in 3 additional machines, which one I will mention later, and just to simply